Welcome to another example of demand forecasting. In this example, we will look at simple and weighted moving average along with their measurement of error. Max's Pizza Point is a small restaurant catering to people with a taste for European pizza. One of their specialities is Max's Special Pizza. So this is the type of pizza which sells the most for Max's Pizza Point restaurant. The manager must forecast the weekly demand for these special pizza so that he can order the ingredients weekly. The recent demand has been given to us in this table. So for the week of 2nd June, the number of pizzas sold was 50. For the week of 9th of June, the number of pizzas sold was 65. For the week of 16th June, the number of pizzas sold was 52. For the week of 23rd June, the number of pizzas sold was 56. For the week of 30th June, the number of pizzas sold was 55. And for the week of 7th July, the number of pizzas sold was 60. Now we are being asked to find out the forecast for pizzas for June 23rd to July 14th by using the simple average method with n is equal to 3. Then repeat the forecast by using the weighted moving average method with n equals to 3 and weights of 0.5, 0.3 and 0.2 with 0.5 applying to the most recent demand. So basically what we are being asked to find out is the forecast for the week of June 23rd, June 30th, July 7th and July 14th. Now we have been given the actual demand for these 3 weeks. However, if we want to find out the forecast that would have been expected based on the previous 3 weeks of data, and also we have to find the forecast for the next week, which is the week of July 14th. Now we have to do this using the simple average method and the weighted moving average method. For the simple average method, we have to consider n is equal to 3, and for weighted moving average method we have to also consider the value of n as 3 and the weights of 0.5, 0.3 and 0.2, with 0.5 applying to the most recent demand. So 0.5 is the weight for the most recent demand, the value of 0.3 will be used for the next recent demand and 0.2 will be for the next recent demand. Also, we are being asked to find out the MAD for each method. MAD is nothing but the mean absolute deviation, which is one of the measurements of error. So let us find out the solution for this example. So this is the information that has been provided to us. June 2nd through July 7th, we have been given the actual demand. Now we have to find out the forecast for weeks June 23rd, June 30th, July 7th and July 14th using simple moving average and weighted moving average. So let's first look at the simple moving average. Now first of all, what is simple moving average? So simple moving average for period t, so let's say this is represented by ft, is equal to the sum of last n demands divided by n. So basically, for simple moving average, we have to take the average of the last n demands. And in our case, we have been asked to consider n equals to 3. So basically what we're saying is, if we have to find out the forecast for the week of June 23rd, we will be taking the average of the last 3 periods available to us, which is June 2nd, June 9th, and June 16th. Similarly, when we move to forecasting for June 30th, we'll take the last 3 demands, which is June 23rd, June 16th, and June 9th. So let's first find out the simple moving average forecast for June 23rd. So forecast is equal to, now we have to take the actual demand, so 50 plus 65 plus 52, 50 plus 65 plus 52 divided by n, which is 3. So this is equal to 5 plus 2, 7, 5 plus 5, 10, plus 6, 16, and this is equal to 55.667, or we can say 56. So for June 23rd, the forecast is 56. Now let's move to the week of June 30th. Now in this case, we'll take the last 3 periods, which is this. So forecast is equal to 65 plus 52 plus 56 divided by 3. So this is equal to 6 plus 2, 8, plus 5, 13. So 1 carryover. Now 5 plus 5, 10, plus 6, 16, plus 1, 17, divided by 3. So this is equal to 57.667, which is also, we can say it is 58. So the forecast for week of June 30th is 58. Let's move to the next one, which is for July 7th. So in this case, the last 3 periods will be these 3. So F3 is equal to 52 plus 56 plus 55, 52 plus 56 plus 55 divided by 3, and this is equal to 5 plus 6, 11, plus 2, 13, 1 carryover, 5 plus 5, 10, plus 5, 15, plus 1, 16, divided by 3. So this is equal to 54.33. We'll round it up to 54. Now let's move to July 14th. So in this case, the last 3 periods will be these 3. So F4 is equal to 56 plus 55 plus 60 divided by 3, and this is equal to, now 6 plus 5 is 11, so 1 and 1 carryover, 5 plus 5, 10, plus 6, 16, plus 1, 17 divided by 3. So this is equal to 57. So for July 7th, the forecast was 54, and for July 14th, the forecast is 57. Now let's calculate the forecast using the weighted moving average method. So what is the weighted moving average method? So as per weighted moving average method, the forecast for period T is equal to the weight of period t minus 1 multiplied by the actual demand for period t minus 1 plus the weight for period t minus 2 multiplied by the actual demand for period t minus 2, so on till the weight of period t minus n multiplied by the actual demand of t minus n. Now in our example, we have been given that we have to take the last 3 periods and the weights given to us are 0.5, 0.3 and 0.2, where 0.5 is to be applied to the latest demand, which means Wt minus 1 is 0.5, Wt minus 2 will be 0.3 and Wt minus 3 will be 0.2. So again we have to find the forecast for June 23rd, or rather the week of June 23rd, week of June 30th, week of July 7th and week of July 14th. So let's first start with the week of June 23rd. So F1 is equal to, now for the week of June 23rd, the last 3 periods are these 3. The latest one being June 16th, for which the actual demand is 52. So At minus 1 is 52, At minus 2 is 65 and At minus 3 is 50. So Wt minus 1 is 0.5, so 0.5 multiplied by At minus 1, which is 52, plus Wt minus 2, which is 0.3, multiplied by At minus 2, which is 65, plus Wt minus 3 is 0.2, multiplied by the actual for t minus 3, which is 50. So let's find this out. So 0.5 multiplied by 52 plus 0.3 multiplied by 65 plus 0.2 multiplied by 50. So this is equal to 55.5. So 55.5 is the weighted moving average for the week of June 23rd. Let's round this number up, so this becomes 56. So this is 56. Next, let's move to June 30th. The last 3 periods is this. So F2 is equal to 0.5 multiplied by 56 plus 0.3 multiplied by 52 plus 0.2 multiplied by 65. So this is equal to 0.5 multiplied by 56 plus 0.3 multiplied by 52 plus 0.2 multiplied by 65. 56.6. 56.6, which can also be rounded up to 57. So for the week of June 30th, the forecast is 57. Next, we have the week of July 7th. The last 3 periods are these. So F3 is equal to 0.5 multiplied by 55 plus 0.3 multiplied by 56 plus 0.2 multiplied by 52. 0.5 multiplied by 55 plus 0.3 multiplied by 56 plus 0.2 multiplied by 52. 54.7. So 54.7, which can be rounded up to 55. Next, we'll forecast for July 14th. Last 3 periods are these 3. So F4 is equal to 0.5 multiplied by 60 plus 0.3 multiplied by 55 plus 0.2 multiplied by 56. So 0.5 multiplied by 60 plus 0.3 multiplied by 55 plus 0.2 multiplied by 56. So forecast is 57.7, 57.7, which can also be rounded up to 58. So the forecast for July 14th is 58. So we have found out the forecast using the simple moving average and weighted moving average, and as we can see, there is a difference. For June 23rd, both are same, 56, 56, but for June 30th, simple moving average gives a forecast of 58, while weighted moving average gives a forecast of 57. For July 7th, simple moving average gives a forecast of 54, while weighted moving average gives a forecast of 55. And for July 14th, simple moving average gives a forecast of 57, while weighted moving average gives a forecast of 58. Now next we have to find out the mean absolute deviation for both these methods. Now what is mean absolute deviation? So mean absolute deviation is, as the name suggests, so first we have to take the deviation, which is actual demand for period T minus the forecast for period T. Then we have to take the absolute value of this, and if we have multiple observations, we of course have to take a sum where T is equal to 1 to n, and then we have to take the mean, so divided by n. So here the values that are needed to calculate the mean absolute deviation is the actual for a period and the forecast for the same period. Now we have these three periods for which we have both these values, which is June 23rd, June 30th, and July 7th. So let's find out the deviation or the absolute deviation value for these 3 weeks for both the simple moving average and weighted moving average. So for week of June 23rd, the deviation or the absolute deviation is AT minus FT. Now AT is this one here, which is the actual demand, and FT is this one here. This is also FT for weighted moving average. So actuals is 56 and the forecast is 56, so this becomes 0. Here the actual is 55 minus forecast is 58, so minus 3, and since we are taking the absolute value, it becomes 3. For July 7th, 60 minus 54, which is 6. So here we have found out the deviation or the absolute deviation for the individual periods. Now we have to take the sum of all of these. So the sum is 0 plus 3 plus 6, which is 9. So the numerator is done. And since we took 3 values, n is 3. So the mean absolute deviation for the simple moving average is equal to 9 divided by 3, which is equal to 3. Now let's do the same calculation for the weighted moving average. So for the week of June 23rd, the actual is 56 and the forecast is 56, so the difference is 0. For the week of June 30th, the actual is 55 and the forecast is 57, so 55 minus 57 is minus 2 and the absolute value becomes 2. For the week of July 7th, actual is 60, forecast is 55, 60 minus 55 is 5. Now taking the sum, so 0 plus 2 plus 5, this is 7. So mean absolute deviation in case of weighted moving average will be equal to 7 divided by 3, which is equal to 2.3. So what this indicates is that for this limited set of data, the weighted moving average forecast gives us less deviation than the simple moving average. However, this is very less amount of data. We need more data to be able to give better conclusions.